And now we're taking the integral from 0 to 1 of this, and thus the area that we're interested in is this region. Well, we talked about this kind of once in class, something like this came up, and Ethan says, yeah, I know what this is because I know that that little region I recognize as geometrically the area that I know is 1/4, and so then that must be 3/4. You guys see this? It's kind of like a picture with 1,000 words. All right, 16, the integral from -1 to 2 of, all right, now things are getting hard. It's absolute value x minus 1 cubed. The best way to think about this is, you guys talked about this in like pre-calc A, right? If you have some function, and then you define a new function to be like the absolute value input of that function, then what does it do? Yeah, it kind of like deletes the whole left side of the graph and replaces it with a copy of the right side. You guys have some very vague memory, like 16 months ago of doing this. Yeah, so how do I graph this? To me, the simplest way to think about this is to take the x minus 1 cubed graph, which looks like, well, it looks like x minus 1 cubed. It's going to be up and then flat and then up like that. And now, if I'm interested in that x being absolute value instead, well, now it's kind of like x is always going to be positive, so only the positive values of this function are relevant. And so it ends up, this function ends up looking exactly like this person said right, well, basically like what this person did right here. A little bit more curvy would have been appreciated. But yeah, yeah, this just gets replaced with a copy of itself, because this function can't tell whether you're plugging in a positive or negative number into it, right? If you give it any number, it interprets that number as if you just gave it the positive version of itself. So, yeah, that's how I used to teach when I taught Greek. Okay. All right. So what we end up with is this very strange function with 3 copies of this area that I know about. But 2 of them are in negative territory and 1 of them is in positive territory, so the answer is negative 1/4. I don't know if you got that. I thought it was kind of hard. You have to do like a lot of things right. All right. 17, I think this is the most interesting one of all. The integral from 0 to 2 of x over 2 cubed. So who did this one? Who put this one up?
Kind of like me.
No one wants to.
Plus Matthew.
Okay. Ethan plus Matthew. Yeah, so alright, I just want to get a bigger picture of this. So the integral from 0 to 2 of x over 2 cubed. Okay, so first off, so here's like 1, here's 2. If I plug in 2, of course, I just get 1. So this is kind of like this, right? And, you know, this function's going to look like that. And the area I'm interested in is all of this. So, it's hard to tell exactly what's going on here. In some ways, it's kind of the same shape, right? Because this original shape that I know about is the integral from 0 to 1. Like this, I know, is 1/4. So isn't this just the same shape? So shouldn't it be 1/4?
But it's stretched out so it's 2 times.
But it's like less too.
No. It's 1/4 of, it's like 2.
It is just
1/4 of 2,
no,
because
no,
it's
but
2
the-
squares instead of 1 square.
Who thinks it's just 1/4 because it's just stretched? It's just the same thing.
No. Look, see, this is 2 squares instead of 1 square. So it's 1/4 of 2 squares.
Yeah, but
That's an interesting way of looking at it. Yeah. He says, oh, challenge over there, Alex. Yeah, Ethan says, look, it is the same shape, but it's this if you accept that this region is 1/4 of this square, then maybe you should accept the fact that this region is 1/4 of this 2 by 1 rectangle. Actually, that's pretty convincing. I'm pretty convinced by that. Anyone else have another thought? There's like about 3 different ways you could do this. Yeah. Oh, now you want to redeem? Oh, counterpoint?
No.
Oh.
I got the same answer. I think it's just like.
Oh, you did.
I think it's. The way I thought about it is like for in the original graph, for every like y value in the new graph, there are like 2 of them. Like every vertical like line in the gap gets stretched out.
Okay, yeah, he's doing like kind of informal 17th century calculus or something like that, where you just think of this area as composed of like an infinite number of line segments, and somehow when you add them all up, you get like area or something in some way. And now he says there are twice as many of them. That's actually kind of convincing. How'd you guys do this one? What went through your brains? I'm actually really curious. Wilson, what went through your brain as you were solving this problem?
I think it's okay.
What did you say? You just said it's 1/4 of the rectangle? Yeah. Amanda Wessel, what'd you do?
I kind of got stuck.
Yeah.
I drew the picture and then I did not.
Yeah. All right, here's one way. Oh yeah, Sid.
Wait, okay, the way I thought of it was like, it doesn't over 0 to 2, if you like that, like if you like cut it in half, doesn't it hit all the same values, or shouldn't it still be the same?
If you cut it in half.
I mean just like for any function, if it's like x over 2 and then you make the interval twice as big from 0, don't you still hit all the same values, and shouldn't the area still be 1?
Yeah, you do hit all the same y values. The y values are all the same.
But what if you just have a horizontal line and then stretch it out?
Yeah, you do have all the same y values. Okay, I think the best way to think about this is by looking at it on a rectangle by rectangle basis. Suddenly then things become super clear. So let's look at this function on a rectangle by, let's look at this integral on a rectangle by rectangle basis. Well, what do? You split it all up into how many rectangles? You know, let's just say n of them. Okay, so let's take the, one of the little rectangles in there. Okay? What is the width of that little rectangle? 1 over n. And its height is whatever it is. Well, now let's take the same corresponding rectangle, right? So go over to like I try to make it the same place. And what is the relationship between the heights of those 2 rectangles, if you're catching my drift? They should be the same. Yet, what is the width of this rectangle? Ah, I think that, to me, that's how I sort of think of this in a way that I find very convincing. You have actually the same number of rectangles. Every single rectangle has the same height as the corresponding rectangle, right? The 27th rectangle in this here is the same height as the 27th rectangle here. But now all the rectangles are twice as wide, and so you do get twice the area.
Isn't that what Alex was talking about?
He kind of said that in an informal way. He said you have twice as many rectangles
Of the same width.
of the same way, which is different. You could also do it that way, but maybe this is more clear. Anyway, all right, good. 18. I think that 18 is the integral from -8 to 8 of x cubed. I don't know anything about x cubed, but I do know that it has to be 0 because it's an odd function. Okay, last 2. 19, the integral from 0 to 1 of x cubed minus 1. So now, yeah, so x cubed minus 1 looks like this. So it's like that. So yeah, it's that area, which we had previously computed was 3/4. So just like this person said, this answer has to be -3/4. Follow? Chanel, follow? Yeah, 20. The integral from 0 to 1 of cube root x. Okay, again, the cube root x function, since it's an inverse of the x cubed function, I kind of know some things about it. And the integral from 0 to 1 of cube root, that has to be... Well, that's not going to do with anything. This has to be... I don't know what that was. But the integral from 0 to 1 of cube root x this has to be 3/4 because this area is 1/4. That's what we computed previously, right? And this area is okay, yeah, so by reasoning it out geometrically, you get that. All right, good. Good, let's have a quiz.
Oh, damn it! I said it too. Sage just said it. You said no.
I just asked what you said.
Yeah, I know. It's time for another one.
I said yes. It's not like all of them not love anymore.
Wait, that's so true. It's not a purpose if they know about it from the video.
Well,
Man, Matthew.
you guys want the easy version or the hard version?
The easy
No, they should get the hard version because they know about it.
I'm crazy, David. I'm a super freak, David. What's the test on the
Oh yeah. Did you turn up?
Yeah, still.
Okay, bye per day. Be back in a few minutes.